This week, we're going to be learning about climate change and the greenhouse effect and learn how the Earth's atmosphere is able to trap enough heat to keep our planet warm. So this is just a summary of the mini lessons that we'll be looking at this week. If you look on the, what we have is for our first essential is we're going to be looking at how greenhouse gases, so greenhouse gases we know are part of our atmosphere. Our atmosphere is made of air, which is a mixture of different gases, and certain of these gases are heat-trapping gases in that they trap some of the heat that is released by the Earth's surface. This effect is called the greenhouse effect. The greenhouse effect is the way our atmosphere works to keep our planet's temperature just right. So in other words, it's not too hot and not too cold. So there's enough of these greenhouse gases in the atmosphere that they trap the heat from the Earth that is released by the Earth, and they keep our planet just at the right temperature for life to exist on our planet. So we're going to go over a little bit about how this works, and also kind of the recent impact from humans on our greenhouse effect, causing what we call the enhanced greenhouse effect, also known as global warming or human-influenced climate change. If you look on this picture here, what you can see is we have a picture of the Earth's surface, and I'm going to try to point out some key features here. One of the key things that you want to look at here is, so we have the surface of the Earth, we have our forests, we have our oceans, bodies of water, our snow. So the Earth is made of a bunch of different surfaces, and as we learned in our weather unit, this all starts with the heating from the sun. So the sun emits a form of radiation we call shortwave radiation. That radiation travels through space, and it goes through our atmosphere, and it reaches the Earth's surface. And as we know from our previous unit, different colored surfaces absorb different amounts of this solar radiation. So all the heating for our planet is coming from the sun. And if you look at those yellow arrows, some of that sunlight gets reflected back, and that could be by light surfaces like snow. When sunlight hits snow or ice, the radiation gets sent back up into the atmosphere and eventually off into space. There are also gases and solid particles in the atmosphere that are also reflecting some of that solar radiation back off into space. So that's one way that our planet is kept cool. So you can think of the glaciers in Antarctica and Greenland, snow cover, the sea ice in the Arctic. Those all play a factor in kind of keeping our planet cool. The rest of that heat, as you can, if you look at the bottom of the picture here, the rest of that heat is energy that gets absorbed by land and water. So all these different surfaces absorb different amounts of the radiation from the sun. Darker surfaces tend to absorb more heat than lighter surfaces such as oceans or different lighter colored surfaces. Once those surfaces absorb the heat, so all the heat gets taken in by the forest, the soil, the sand, the deserts, the rivers, the oceans, the Earth then gives off a different form of radiation. That type of radiation is called infrared radiation. It's a radiation we cannot see. It is a weaker form of radiation. It travels at a longer wavelength than the radiation coming from the sun. So what happens when the Earth releases that infrared radiation? This is where the greenhouse effect comes into play. So that's what I'm going to go over right now. So what happens is the Earth's surface gives off a form of long wave radiation we call infrared radiation. So the planet gives off heat, much like you give off heat when you're sleeping in your bed at night. You put a blanket over yourself, and as your body gives off heat, the blanket traps some of that heat. So what happens with the Earth is the Earth gives off this infrared radiation, and there are certain gases in our atmosphere that are in this mixture of air that will take some of that heat that is absorbed and absorb it and re-emit it back into and keep it essentially in our planet. So these gases that are over here, these are called greenhouse gases. So greenhouse gases are these gases that are in our atmosphere in just the right amount to trap some of the heat that is being given off by the Earth's surface. What do they do with that heat? They absorb that heat, they begin to move faster, and they vibrate when they absorb that heat, and eventually what happens is they re-emit that heat back Earth's surface. So all the heat from these gases gets re-emitted back to the surface. And this is what we call the greenhouse effect that keeps our planet kind of at just the right temperature. These greenhouse gases include some of the ones on the left side of the picture. So one that we've talked about quite a bit is water vapor. So water vapor, you guys know, is when water evaporates and turns into a gas. So there's water vapor in our atmosphere that traps heat, so it's a greenhouse gas. Another gas is called nitrous oxide. So these gases are greenhouse gases. They're in very small amounts. Nitrous oxide, you can see by the chemical makeup, is 2 nitrogen atoms bonded to 1 oxygen atom. And this is a greenhouse gas that traps heat. Another one is a gas called methane. So methane is CH4. So it's a carbon molecule, as you can see in the middle here, and it's bonded to 4 hydrogen atoms. And the big one is carbon dioxide. So carbon dioxide is one of the chief greenhouse gases. Carbon dioxide is a carbon atom bonded to 2 oxygen atoms here. And we'll talk more about carbon dioxide's role in the atmosphere. But the common thing that all these greenhouse gases have in common is they have to have 3 or more atoms. Essentially, this chemical makeup for a gas allows them to absorb the infrared heat and then re-emit it. Gases like O2, oxygen that we breathe in, is not a greenhouse gas. It is essentially too small. It doesn't absorb the heat like these other greenhouse gases. So that's what these gases do. If you look back at the main picture here, just to summarize, is you get this energy coming from the sun. And the greenhouse gases, a common misconception is they absorb the sun's energy. That's not true. Greenhouse gases, they absorb the heat that the Earth then releases back up into the atmosphere. So it's very important that we have just the right amount of greenhouse gases in the atmosphere. Too few will make the Earth too cold. Too many, obviously, will make it too hot. One of the things we're going to talk about later this week is the role of humans on enhancing our greenhouse effect. So the word enhance means to make stronger, to make work better. And in this case, it's not actually a good thing. So the enhanced greenhouse effect is what many people commonly refer to as global warming. When you add too many greenhouse gases into the atmosphere, it makes the planet too hot. And what we're seeing now is there's a lot of activity. Many of it is human activity, things like industries, transportation, farming, large-scale farming, the effect of glaciers and ice caps. All these things are adding more greenhouse gases up into the atmosphere, and that is making our planet warmer. Some human activities that cause greenhouse gases, you can see, transportation. So when we burn gasoline in cars, that emits carbon into the atmosphere. Large-scale farming. So this picture right here is a picture of large-scale livestock cows. So large agricultural areas tend to emit different greenhouse gases. In this case, this would be methane. Large-scale farming. So farming on larger scales releases a lot of gases that are trapped in the soil. When farms, basically churn up the soil, there's carbon that is in the soil that is released. Industries is a big one. So you can see here, industries to generate heat and electricity in factories. Fertilizer use. Fertilizer use puts a gas, nitrous oxide, in the air. Mining is another one. So you can see mining, large-scale mining operations. And another, one of the rather big ones is clear-cutting rainforests and trees. So trees absorb a lot of the CO2 in the atmosphere, and one of the problems on the Earth is we're clearing large amounts of rainforests and forested areas for farming, for urban expansion. And sometimes when we clear those forests, they do what they call slash and burn, which is what you see here. They chop down the trees, they transport the trees, they burn the area, and releases a lot of gases in the air. So the big question is, with this enhancing of the greenhouse effect, what are the impacts on various factors, which is something we're going to think about in class. So what are some indicators, so signs of a warming planet? So the big question marks are what are going to happen to glaciers, what happens to the amount of snow cover, the forest areas, ecosystems, the change in the seasons, species migration. So these are all things, things like sea ice in the North Pole, the sea level, how will sea levels change with a warming planet, ice sheets down in Antarctica, how would they be impacted by climate change, the temperature of the ocean, the temperature of the atmosphere, temperature over oceans, and the humidity. So these are all big question marks. What is going to happen in the future as we add more greenhouse gases and we enhance the greenhouse effect? So that's one thing we're going to think about. You guys will make a hypothesis as to whether these things will increase or decrease with a warming planet and come up with some reasons. So one of the questions we often get asked when we do this unit is, what is some of the evidence? This large graph you see here, if you look at the top, it's the relationship between one rather important greenhouse gas called carbon dioxide and the temperature of the Earth. Carbon dioxide is a gas that is, like I said before, it's a greenhouse gas, and as the atmospheric CO2 increases, so does the Earth's temperature, because more CO2 will trap more heat, making the planet warmer. This is very important because the carbon dioxide levels in the atmosphere are higher now than they've been in the last 400,000 years. So what this graph is showing you, hopefully you can see two lines on the graph. So the bottom of the graph is the years before present. So present is 0 day, is 0 here. So here's 2017. And then as I go this way, it goes farther back in time, so 50,000 years, 100,000 years, 150,000 years, all the way back to 450,000 years. The blue line that you can see rising and falling, so this blue line right here is the average temperature of the Earth. So what you hopefully could see is that over long periods of time, you have kind of these warmer periods, and then towards the bottom of the graph, you have these colder periods. These bottom sections right here are ice ages. So these are the ice ages, all these low points, and then these are the warmer periods here, what we call the interglacial periods. So over the last 450,000 years, we have this nice cycle of warm, cold, warm, cold, warm, cold. And if you look at the graph, what you'll notice is the blue and the red seem to line up. So in other words, the red is the carbon dioxide in the atmosphere. So this red line is the amount of carbon dioxide in the atmosphere. And CO2 is a greenhouse gas that traps heat. And it's one of the chief greenhouse gases that we're going to be talking about. And if you look at this graph, what you notice is the blue and the red lines tend to follow each other almost precisely. So when the red line rises, so does the blue line. It gets warmer. When the amount of carbon dioxide goes up, the temperature goes up. When the amount of carbon dioxide, if you look down here, when it goes down, the temperature goes down. What's concerning is present-day carbon dioxide is presently at this point right here. So the red line, it's hard to see it. It goes all the way up to here. So that's where we are today. And I'm going to show you the previous high points. So the previous high points in carbon dioxide, there's one right here. There's the CO2 high point. Here. Here. And right here. Over the last 450,000 years, CO2 has never gone above about 280 parts per million. So it's just a unit of measurement for measuring gases. And here we are today, we're kind of approaching about 380 parts per million. So we're way above where we've been anywhere in the last 450,000 years. So one way we look at evidence for climate change is we measure the amount of gases in the atmosphere. So again, this is the carbon dioxide measurements in the atmosphere, and basically we are at 2017 right here. We're looking just at about 10 years of data here. What you notice is the carbon dioxide has just steadily risen. And again, that's attributed to the use of fossil fuels, farming. A lot of this is human impact. This other graph here is the temperature. So this is the average temperature of the Earth and how it changes over time. And if you look at the last kind of 100 years, so here's where we are about 2017, and we go back about 100 years, the temperature has slowly risen to where it is today. So we've had, some of our warmest years ever on record have been in the last 5 to 6 years. A lot of that is attributed to this enhanced greenhouse effect. So just want to give you one visualization on how the enhanced greenhouse effect works. So if you examine the picture here, this is the greenhouse picture here. The enhanced greenhouse effect is when we have too many of these greenhouse gases that are in the air. I'm just going to reorder this for you. So basically, if you think of the enhanced greenhouse effect as, the regular greenhouse effect, we have just the right amount of greenhouse gases in the atmosphere, and it's keeping our planet just right. It's trapping, again, the heat that is being released by the Earth's surface, not the heat from the sun. Things like burning fossil fuels for automobiles and factories add additional CO2 in the atmosphere. So I'm copying and pasting a bunch of carbon dioxide in the atmosphere, and what we've seen is, as we add more greenhouse gases into the atmosphere, these greenhouse gases then start to trap heat, and carbon dioxide is not the only one. Methane is another greenhouse gas that comes from the soil and livestock. Nitrous oxide, this one over here, comes from heavy fertilizer use and fertilizer production in farms. It's released, so when we add more of this gas into the atmosphere, so now here's all my greenhouse gases. When the Earth releases its infrared radiation, you have all these greenhouse gases that are trapping the heat, and if you look at that orange arrow that's going back down to the surface, they're sending that heat back down to the surface. So what we'll talk about this week is we'll focus on the greenhouse effect and how it works with these greenhouse gases. We'll talk about the enhanced greenhouse effect. And again, some of the evidence is really important. So with any scientific theory, we need to think about evidence. And then we'll get into effects as well. So effects are things like the melting of ice caps, melting of glaciers in Greenland, etc. And we'll also get into, at the end of the week, solutions. So this is not a global warming is not an unsolvable problem. We're starting to see some of the technology being developed and being used. We know about things like solar power, wind farms, hybrid vehicles, organic farming, natural ways to raise livestock rather than in large-scale industry-type farming. And I'll also talk about what we can do with, carbon dioxide in the air and carbon that's produced by factories and stuff. It's called carbon sequestration options. Okay, so that's basically a summary of the week. You guys will also be looking at some data from a website. This website is NASA's climate change, and you can see they have. Let me just pull up some data here. This is carbon dioxide. You can see here the graph, and if I play this, it shows you how. So the yellow and the orange is higher levels of carbon dioxide, and you can see how much it's actually risen over time. So this is all stuff that we'll get into in our climate change unit. Okay, thanks, guys.